vertical, right?
Yeah, vertical is standing line
They
like
are
this. These are the
so
group.
they are 18.
18 group. Okay, thank you. So they are the vertical line. These are the known as what? That is going to be the group, right? Now that is we study, that is down the group we study the radii. What was the radii? Do you have any idea? Radii, it was increasing or decreasing down the group?
Yes, sir.
Increasing or decreasing?
Increasing.
Okay, thank you. So down the group radii increasing. Another one more factor I taught you, Janab, if you keep in mind, that is metallic character I told. Metallic character. Do you have that one? Metallic character. What is happening down the group? Metallic character. Like we are going lithium,
Metallic character.
potassium, rubidium, cesium. Down the group, what is happening? Increasing or decreasing?
Increase.
Increasing. Thank you. It is increasing, right? Metallic character is increasing.
Yes.
Okay. So these things we already studied. One more factor we study, little tricky one. Okay. What we study? Ionization energy. Do you have any idea about ionization energy? That is, it is going to increase or decrease. Keep while thinking, firstly think, then answer. Ionization energy is going to increase or decrease?
Increase.
What?
Increase.
No. Decrease. It is
Decrease.
decrease.
Okay.
That you need to keep in mind, because ionization energy means that amount of energy required to remove the electron, right? So what is happening
Yes.
down the group?
Can you explain ionization energy once more?
Okay,
It's
sure.
like in brief.
Okay. Ionization energy. So if we talk about ionization energy, so that is the amount of energy. Here I am writing the amount of energy. Okay, amount of energy required to remove an outermost electron. Okay, amount of energy required to remove an outermost electron. Okay, so how, if the more energy required, okay, more energy required. So if energy required is more, so that is, it is going to be more IE, more ionization energy. Getting my point? If the energy required
Yes,
more,
sir.
so that is more ionization energy. Now we need to keep in mind one thing. If attraction is more, see, if attraction is more, attraction is more, where? Between, B by W means between nucleus and outermost electron. Nucleus and outermost electron. If attraction is more between nucleus and outermost electron, then, right, then IE will be more. IE will be more. That we need to keep in mind. I will be more, right? IE means ionization energy will be more. Now see, attraction is more between nucleus and outermost electron. So more energy required to remove the electron. Why? You may be able to understand this, that if the size is small, so positive proton nucleus and negative electron is close. Yes or no? If the size is small, so that is distance between outermost electron and nucleus will be less. Yes or no?
Yes, sir.
So attraction will be more. Small size means attraction is high.
Yes, sir.
So more energy required or less energy required?
More.
More. Thank you so much. So more energy required. So ionization energy will be more energy required. So ionization energy will be
More.
more. Now see this one. So what the point I am saying? See, so lithium, sodium, potassium, rubidium, cesium. See, 3, 11, 19, 37, 55. 2, 1. Here is 2, 8, 1. Here is 2, 8, 8, 1. Here is 2, 8, 8, 18, 1. Here is C 2, 8, 8, 18, 18, 1. means number of cell. These are the number of cell. KL, here is KLM, this is KLMN, this is KLMNO, here is KLMNOP, right? So here what is
Yes, sir.
happening? What is happening? Here is the two cell KL. Here you see how many cell? 3 cell. Here you say next one is 4 cell. Here you see next one is number of cell is keep on increasing. So Janab, you see here is the electrons are there na, in outermost cell. Here electrons are there, and this is the positive charge nucleus is there. So you please tell me when will be attraction between plus minus high? When distance is less or more? When is
When
attraction
distance is
less? If distance is less, so
less.
attraction will more. Now opposite charge will attract.
Yes, sir.
Huh. So if more attraction is there, so it is difficult to remove the electron. Yes or no?
Yes, sir.
So difficult to remove the electron. It means more energy required, and more energy required means ionization energy will be high. Yes or no?
Hi.
Yeah.
Yes, sir.
So see. So down the group, what is happening? Down the group, IE increases. Down the group, IE increases. Yes or no?
Yes, sir.
No. Sorry. Down the group, size increases, not I. Size
Size
increase.
increases.
Size increases. Attraction decreases. Yes or no? Attraction
Yes, sir.
decreases. So what is happening?
Yes.
So less energy required. So less energy required. So less energy required. So if less energy required, so what is happening? What is happening? Less energy required. So what is happening? IE decreases. Less energy required, na?
Decreases.
Understood this
Yes.
one. Sure.
Yes, sir.
Okay, thank you very much. So, see, then I'm asking one problem. Which have
Okay, sir.
which have least IE? Which have least IE? See, here question is there. Fluorine, chlorine, bromine, iodine, statine. So they are saying out of this, which is having least IE?
Yes, sir.
Guess the answer.
Hmm. Less IE. Wait, sir.
IE means
Wait,
ionization
sir.
energy. Ionization energy.
Ionization energy.
Hmm.
Chlorine. Sir, fluorine.
List.
No. Wait, least ionization energy. Oh, sorry, sir. Wait,
This is
least
group 17.
ionization energy 80.
80. Thank you
80.
so much. Okay, thank
Hmm.
you so much. You are trying to understand. This is okay. So they are the group 17. They are the group 17
Hmm.
element. Now, question. See, which have most IE? Which have most IE? Okay. If I am asking which have most IE, so see beryllium, magnesium, calcium, strontium, barium. So this is A, B, C, D, and E. Most IE. Can you guess?
Most IE. Wait.
Most means highest.
Beryllium. Yeah, wait, sir. I know. Wait, sir. Which group, sir?
The group 2. They are the group 2.
Okay, beryllium.
Hmm.
Which have the most IE.
Okay, great.
Okay, beryllium, sir.
Thank you. So beryllium is most IE. So I hope it is the clear to you. Next,
Yes, sir.
can I go to next factor?
Yes, sir.
Next one is electronegativity. Next factor is electronegativity. Electronegativity. This is in the short form. It is also called E and N. Electronegativity. Okay. This
Yes.
is the amount, that is how much you can write different way. It is
Yes, sir.
tendency. It is tendency of group of atom, tendency of covalently bonded atom, covalently bonded atom, covalently bonded atom, covalently bonded atoms to attract shared paired electron, to attract shared paired electron. Okay, so here you see it is tendency of covalently bonded atom to attract shared paired electron towards itself, towards itself. Okay, so that we need to keep in mind. What the point here you see, suppose we are having that is HCl, this is the covalent bond. So out of H and Cl, Cl will attract this lone pair electron to the here. No, these two electron means that is the bonded electron. So this bonded electron will shift. Now it is in the center, resulting you see that is H and Cl. So here is this is negative negative. So both the negative charge is where? Near to chlorine. Okay, so it is going to be negative, it is going to be positive. Now you see what is happening here. Now you see what is happening here. This is the negative and this is the positive. So it is tendency of covalently bonded atom to attract shared paired electron towards itself. So this electron is going to which direction? Near to the Cl. Getting my point? Why? Because Cl is more electronegative. Because Cl is more negative. Why Cl is more negative? Because Cl size is smaller. Let's try to understand this with the help of the group. Okay, so I'm just going for the variation in group. Let's see variation in group.
Yes, sir.
Okay, it is the what variation in group of what is there? Group of En, electronegativity. Okay, variation of En, variation in group of En, electronegativity. So suppose
Yes,
I am
sir.
taking fluorine, chlorine, bromine, iodine, this I2. Fluorine is 9, chlorine is 17, it is 35, and it will be, if I will add 32, so how much will come? 7, 67, it is coming. So here you see what is happening. If you see, that is 2 and 7. Here is 2, 8, 7. Here is 2, 8. Then in going to be 8. Then 18 and 7. So you can add out 8, 8, 16. 16. That is 18, 18, 18, 36. 2, 8, 18 simple. This is not 2, 8, 18, 7. Now it will be okay. See, 2, 8, that is 10. 10 and 18, it will be the 28 and 7. So that is how much? 5 and 35. That is correct one. So here you see, next one you go. Here, 2, 8, 18, 18, and something will be 7. So number of orbit you see, number of orbit. So number of orbit, this is the KL. Here is KLM. Here is KLMN. This is the KLMNO. These are there. See what the point?
Yes.
Important point you see. What the point? Here is the fluorine you see. Fluorine is having small sizes, you know. Compared to iodine, the size is iodine size will be high. Yes, or no? Yes, or no?
Yes, sir. Yes.
Very good. Now, Janab, here see, I'm making the covalent bond. So here I will meet
Yes,
HF,
sir.
then I will meet HCl, then I will meet that is HBr, and then I will meet HI. Janab, one point
Yes, sir.
which is important point that you need to keep in mind here is that is the smaller size have more attraction. Smaller size has more attraction. That's very sure. Yes, yeah, no.
Yes, sir.
So smaller size has more attraction, means tendency to attract pair paired electron will be also high.
Yes, sir.
So if I will ask from you, Janab, so out of this, these two electrons are there. Single line means two electron. So which will attract the shared paired electron strongly? Which will? Fluorine, chlorine, bromine, iodine. A small size, more attraction. Large size, less attraction. Tell me.
Yes, sir.
A small size means more attraction by nucleus. So lone pair electron will be attracted more. A small size. Larger size means
Yes.
attraction will be less.
Yes.
So in which case HF, HCl, HBr, HI, which case attraction will be more?
Sir, can you repeat?
Which will attract more? Which will? Either fluorine will attract lone pair
Sir,
or iodine.
sir, I would no chlorine.
Fluorine. Thank you so much. Okay. So you thought too much second time, but you replied correctly. Okay. So Janab, when you are going down the group, so that is En decreases. Okay, because tendency to attract lone pair decreases means electronegativity decreases. Getting my point?
Yes, sir.
So here you see, it is tendency to attract tendency of covalently bonded atom to attract shared pair electron towards itself. Okay, so here what is happening? It is attracting, right? It is attraction
Yes,
is
sir.
fluorine is a small size, so more attraction shared pair electron. Here is so I'm
Yes,
writing.
sir.
So down the group, here you see, down the group, electronegativity, down the group, electronegativity decreases. Okay, electronegativity decreases as what? Down the group, electronegativity decreases as what is there? Down the group, electronegativity decreases. Reason what? As size
Yes, sir.
increases, size increases, and attraction between attraction between
Yes, sir.
attraction to you can write attraction to shared paired electron also decreases. Shared paired electron also decreases. Down the group, electronegativity decreases as size increases, and attraction to shared paired electron also decreases. Is it is
Yes,
it
sir.
is it correct?
Yes,
So that is what the concept of electronegativity. One more small factor is there that can we write. I'm erasing this one. I'll share you the PDF.
yes, sir.
Okay. Hmm. Please, you
Yes,
do
sir.
solve the whatever question you are having. You do solve. If you don't have the question, you ask me. I will share the question. Okay. Because
Okay, sir.
1 hours you are dedicating online, very difficult, and also you are paying also, so it is very difficult. So I am all about to cooperate you, whatever you are flexible, how much you want, I am ready. Okay, if you want some any days you want time, sir, give me 10-minute time. I am stuck in topic. I will give a 10-minute time, 20-minute time. I have no problem to give time to you, right? Any day you can ask, sir, give me
Yes,
extra
sir.
10 minutes. I will give extra 10 minutes, extra 20 minutes, extra half an hour. You can ask anytime. Getting?
Okay, sir.
Last factor is there, and that is what? Electron gain enthalpy. Electron gain enthalpy. Electron gain enthalpy. This is the point. Okay. Electron gain enthalpy. What is electron gain enthalpy? The amount of energy, they are saying, see, the amount of energy released when, what they are saying, the amount of energy released when, what the point is there, what the other point, the amount of energy released when, okay, when an extra electron, when an extra electron is added to, when an extra electron is added to, the amount of energy released when an extra electron is added to isolated gaseous atom. Isolated gaseous atom means,
Yes, sir.
means they are saying, if you want to remove the electron, you need to give energy. But if you want to add
Yes,
the
sir.
electron in atom, energy itself release.
Yes.
Keep in mind once. If you want to remove the electron, you need to supply energy. That is called ionization energy. But if you add electron, energy itself release, and that is known as electron
Yes,
gain
sir.
enthalpy. Is it okay? Is it okay?
Yes, sir.
Okay. Thank you. Thank you so much. So what I mean to say here, that is amount of energy released when an extra electron is added to isolated gaseous atom. Suppose Cl is there, and what I am adding, one electron adding. So what will happen? Cl minus will convert, and what will there? That is energy will release. Energy release. Okay. This is what is the energy released. See. Energy release. And this energy release is known
Yes,
as
sir.
what? Electron gain enthalpy. Electron gain
Again.
enthalpy.
Yes, sir.
This is electron gain enthalpy, right?
Yes.
So that is what the point, if you can understand. See, what the point they are saying, on moving down the group, that is what important. Variation in group, here is point is there. Variation in group. Variation in group. So what they are saying,
Yes, sir.
on moving down the group, on moving down the group, on moving down the group, okay, what is going to happen? On moving down the group,
Yes.
less amount of energy, less amount of energy, less amount of energy released, less amount of energy released on addition of, on addition of an extra electron, an extra electron to an atom, to an atom.
Yes,
So,
sir.
so what is happening? So extra electron to an atom. So electron gain enthalpy decreases down the group. Electron
Yes, sir.
gain enthalpy, electron gain enthalpy decreases down the group. Okay, this is the what? Decreases down the group, down the group. This is what the point.
Yes, sir.
So will you be able to understand this point? What is happening? They are
Yes,
saying
sir.
that is the if the atom is a large size, easily electron will get added and less amount of energy will release. Less amount of energy will release. So when you are moving down the group, electron gain enthalpy automatically going to decrease. So here what the point they are saying, you see, on moving down the group, less amount of energy released on addition of an extra electron to an atom. So electron gain enthalpy decreases down the group. This is the point. Getting?
Yes, sir.
Hmm. So if I will ask the question from you, which have, okay, largest electron gain enthalpy value, electron gain enthalpy value, gain enthalpy value. See, keep in mind, enthalpy value, that is
Yes,
more energy, more energy, more energy released, more energy released on, that is more energy released on what? What the point they are saying? More energy released on, another point what we can write, more energy released on adding one electron. See,
yes,
adding
sir.
one electron. Keep in mind, na, keep in mind definition. Okay, I told you, Janab,
Yes,
if the atom is large size, repulsion is less, easily electron you will add, so less energy will release. Okay, this is very tough. Actually, this point is critical one. So here that is the lithium, sodium, potassium, rubidium. See the note I am writing note. Okay, large
yes,
atom,
sir.
large atom, large atom, less repulsion, large atom, less repulsion, less repulsion, less energy release. Okay, less energy, less energy released, less energy
Yes,
release, less energy release, less energy release, it means less energy released, it means electron gain enthalpy is less, electron
yes, sir.
gain enthalpy is less, electron gain enthalpy is less. Can you please tell me this answer? A, B, C, D.
Wait, sir.
Hmm. Large size, less repulsion, less energy release, electron gain enthalpy is less. So they are asking largest means most, which have most electron gain enthalpy. So if I will ask you, if I will ask you that you are adding the electron, the atom is large size, easily you can add. Atom is small size, so difficult to add. So that is more energy will release, more energy will release. So they are asking the
Yes, sir.
question that is in the lithium, sodium, potassium, rubidium, in which case more energy will release.
Wait, sir.
Hmm.
Largest,
Think.
less repel, largest atom,
Hmm.
large atom, less repulsion, less energy release. Wait,
Hmm.
sir.
Hmm.
I know.
Hmm.
Sir, lithium, sodium, potassium,
Hmm.
rubidium. Sir, rubidium.
No, see, largest atom. This is large size, na? This is large size,
Large
na?
atom, yeah, less repulsion.
So less repulsion means less energy released. So less energy,
Yes,
so less electron gain enthalpy. So less electron gain
yes,
enthalpy. They are asking largest electron gain enthalpy.
yes.
So this is the,
Acha, then lithium.
yes. Now you understood. This is lithium. Got it.
This question was confusing.
This is question. So Janab, everything we study in the group, right? Everything we study in the group, whatever the required thing are there, we study. Okay. Some other factors are there like that valency. If you talk about valency in group, valency. Valency means what? It is combining, it is combining capacity, it is combining capacity of atoms, it is combining capacity of atoms, it is combining capacity of atoms. Okay, what the point? Combining cap. Suppose oxygen combine two bond. Okay. Yeah, that is also you can form. It is number of bond. It is number of bond. It is number of bonds formed. It is number of bond formed. It is number of bond formed between two atoms. Between
Yes,
atoms.
sir.
Here. So here is two bond is there. This is double bond, yes or no?
Yes.
So double bond means if you talk about uh, mm, so double bond is there. So if you can say valency, how much will be there? 2. If the nitrogen and nitrogen triple bond is there. So here if you talk about valency, this is triple bond, so valency is 3. If I will go H single bond H, so single bond is there, so
Yes.
valency is going to be what? 1 or 2? How much? Getting this point? Are you be able to understand this?
Yes, sir.
It is combining capacity of atom, or it is number of bond formed between atoms. So these are the point. So example 1, example 2, example 3. This is the 3, right? Is it okay?
Yes, sir.
Okay, thank you. Now let's do the second point. Let's do the second point. What is the second point if you talk about? So methods to calculate valency. Okay, little bit
Yes,
this
sir.
is the extra from this chapter. Methods to calculate valency. Calculate valency. So what they are saying, method to calculate valency. Rule 1. If number of electron, if number of valence electron, if number of valence electron is 1 to 4, if number of valence electron is 1 to 4, then valency is how much it is going to happen. If number of valence electron is more, okay, if number of valence electron is 1 to 4, then valency is equal to number of valence electron, equal to number of valence electron, equal to number of valence electron, right? So see,
Yes, sir.
so if you see, suppose if you can go for the sodium, sodium is 11, so valency 281. This is the valence electron. Outermost cell, this will be there. This is the K, this is L, this is M. So this is outermost electron, outermost electron. So outermost electron. So number of valence in number of electron is how much? Number of electron equal to 1. So number of electron is equal to 1. So valency is going to be how much? Valency is equal to 1. Getting?
Yes, sir.
See, rule. This is the rule number 1. Suppose I am going nitrogen. Nitrogen is 7, 2 and 5. No. Nitrogen will not fit on the in this rule. Okay, it can be for the boron. Boron can fit. Boron is 5. So 2 and 3. 3 is less than 4. 1 to 4. So 3 means outermost electron. This is the outermost electron. Outermost electron is equal to 3. So it is going to be what? It is going to be valency is equal to, it is going to be 3. Yes, yeah, no.
Yes, sir.
So this is the rule number 1. Now we are going to. Acha, I am asking one question. If you don't mind, I will ask the questions. Question.
Yes, sir.
What is valency of beryllium? What is valency of beryllium? Okay, this is atomic number 4. So that is A number they are saying 1, B number they are saying 2, C number they are saying 3,
Yes, sir.
D number they are saying 4. E number you can write 5. Guess. Rule, keep in mind rule. You are not because the time is less for you, because 3 days you are studying, you need to study so many chapters. so that I am not giving you time to write. I am sharing the PDF. Please write
Yes,
down
sir.
some important point now,
So
please.
that's why, sir, I'm getting a bit confused. I'll write after the class.
So if you want to write also, I will give the time. Okay, you.
But sir, it will take much time now.
That is the point. Okay, but that is what it is, your choice, you know. Whatever you think, you please tell me. If you want to write, I'll give the time. So Janab, you see now what they are saying. You need to do the configuration. Like here, I did the sodium 281. Okay, so they are saying if the valence cell, number of valence cell means outermost cell. So if 1 to 4 electron is there, means valency will be 1 to 4. So guess beryllium is there. Can you solve? So first cell is 2 electrons. So second cell will be how many? Total electron is 4. So K cell is 2 electrons. So L cell how many electrons? Tell me.
Wait, sir.
Total electron is 4. So K cell is 2. So remaining how many? 4 minus 2, that is 2 now. Yes, yeah, no.
Yes, sir.
So this is valence electron. So this is valence electron. It means if this is valence electron, Janam, if it is this is valence electron. So if you, I will ask that is what is valency? What is valency? So valency is going to be 2.
2.
Got it?
Yes, sir.
So this is our.
Yes.
Is it okay?
Yes, sir.
So will you be able to understand this?
Yes, sir.
Okay. Now, next point. Variation of valency in group. Variation of valency in group. Valency in group. So what is on moving? They are saying on moving down the group, on moving down the group, on moving down the group, number of,
Yes,
on
sir.
moving down the group, number of, on moving down the group, number of valence electron is same. Number of valence electron is same.
Yes.
Number of valence electron is same. Number of valence electron is same. So on moving down the group, number of valence electron is same. So
Yes.
on moving down the group, number of valence electron is same. So valency down the group, valency down the group, down the group, valency down the group is constant. Valency down the group is constant. Getting?
Yes, sir.
Okay. Can I erase? So
Yes, sir.
next page. Here you see. Question 1. What is valency of group 1 element? There's a question. What is valency of group 1 element? The point is, what is valency of group 1 element? So here is group 1. So
Yes.
I am writing the element itself. You need to reply the answer. Lithium, sodium, potassium, rubidium, cesium. Here is 3, 11, 19, 37, 55. So here is 2 and 1. Here is 2, 8, 1, 2, 8, 8, 1. Here is 2, 8, 8, 18, 1. 2, 8, 8, 18, 18, 1. Now, this is 1.
Yes, sir.
Here is the point. These are there 1, 2, 3. Right?
Mm.
Now, what we need to do, here, number of valence electron is how much? Can you tell me? How many valence electron is there?
Valence electrons 1 1.
1. Thank you so much. So number of valence electron is 1. So what will be the valency of these all the element?
All the elements
Means
1.
each element 1, na? Yes or no?
Yes.
So valency is 1 for all the element. So valency in group is what? Same or different? Valency in
Same.
group is same or different?
Same.
Same. So our that is, you understood what is happening valency in the group?
Yes, sir.
Okay, okay, okay. Thank you. Now the next point, let's try to understand the next point. Now we need to study the period. Okay, period. What is period? Can you tell me period in periodic table? Group is vertical column. So what is period? What is left? Horizontal. Yes or no? It is
Yes, sir.
horizontal. It is horizontal rows. It is horizontal rows in periodic table. It is horizontal rows in periodic table, right? That is elements, that is elements left to right, element left to right, element left to
Yes.
right in periodic table, in periodic table, in periodic table.
Yes, sir.
Can you understand this?
Yes, sir.
Hmm. So solve it. Can you understand this, the period?
Yes, sir.
Okay. So can I erase this one?
Yeah.
So how many period is there? Question I'm asking. How many period present? How many period present in long form periodic table? In long form periodic table. How many period present in long form periodic table? You tell me. A number 1, B number 4, C number 6, D number 7. Same one more question. How many group? This you will answer second one. How many group present in long form periodic table? Long form periodic table.
How many groups are present in long form periodic
Periodic
table?
table. So they are saying 1, 10,
7.
15, 18. So firstly you reply the answer number question 1, then answer
First
number.
one is option D.
First one is option D.
7.
Thank you so much. So option D, 7 period are there. Second one.
How many groups represent in long form periodic table? 18.
18. So that is okay. Now Jainam, what we need to study, okay. So following things, variation of, we need to study variation of uh,
Yes, sir.
property in period, or we need to properties in period. What are the properties? Whatever we study, Anna, whatever is study in the group, that we study in the period. What is period? If you talk about the, we need to study valency, we study. Second one, we need to study ionization, study enthalpy. Third one, we have to study atomic radii. This all the property of
Yes, sir.
whatever we study, that we need to study in the group also. Okay, atomic radii.
Yes,
Okay,
sir.
one another factors are there. Electron gain, electronegativity. Fifth number, electronegativity. Okay, this all the things. Okay, electronegativity. And last one is there, sixth one, metallic character. This one, this all we have to study in the period. So can we study in the next class, or you want, you have the concentration till now?
No, sir. Next class.
Next class. So okay, Janam. I'll share you the PDF. You can also share the problems from your book of this chapter. No,
Okay, sir.
you can take 1-2
Okay,
page.
sir. I
Okay,
will.
no need to send all the pages because
Okay,
it will
sir.
take time.
Okay.
One page you can say is exercise, one question. One page you take the pic directly on WhatsApp camera and send to me. Okay, I will solve and I will share some problem to you. Right.
Okay, sir.
So okay, bye. Take care.
Bye, sir.
नासा सुन रही हो?